Hello everyone, my name is Dr. Aadesh Pratap Singh. I am an Inspire faculty at Indian Institute of Technology, New Delhi, India. For Young Scientist Competition 2014, my name was nominated by Professor Misail Mosler. I am working in the new Indigo project entitled Innovative Material System for Solar Energy Harvesting in a Photoelectrochemical Cell as a co-principal investigator from Indian side. As you know that hydrogen is considered as a fuel of future due to its many attractive properties like eco-friendly nature, high heat of combustion and energy storage capacity per unit volume as compared to oil and petroleum. Therefore, the major challenge for scientific community is how to generate hydrogen from renewable sources. So here in this project, the idea is to split water into the hydrogen and oxygen using solar radiation. But as the water is transparent for UV and visible part of solar radiation, therefore a material medium is required that can absorb this solar radiation and split water into its constituents. Hence the hydrogen produced in this system will known as the solar hydrogen. So here this is a photoelectrochemical cell for the splitting of water, and these are the electrochemical reaction involved in the production of hydrogen and oxygen at the respective electrodes, and the hydrogen produced in this system can be used for the transportation of vehicles, electricity generation and also for the domestic cooking. So this slide will show you the basic principle of splitting water in a photoelectrochemical cell. Here one side is the n-type semiconductor and another side is a metallic counter electrode. When this semiconductor is illuminated with the solar radiation having energy greater than the band gap energy of the semiconductor, it will form an electron-hole pair. These electrons and holes will move towards the favorable direction and participate in the redox chemical reaction to split water into the hydrogen and oxygen. So overall efficiency of a photoelectrochemical cell is mainly depends upon the properties of this semiconductor material. So this semiconductor material is considered as a heart of a photoelectrochemical cell. So for an ideal semiconductor to be used in a photoelectrochemical cell for efficient splitting of water, it should have many properties. The first one is its band gap should be in between 1.5 to 2.5 electron volts so that it can absorb all UV and visible part of solar radiation. The bandage position should be matched with the redox chemical potential of water to facilitate the easy transfer of charge carrier at the semiconductor electrolyte junction. The material should be stable in a aqueous solution and should be less expensive. So main research in this area is to find out a semiconductor capable of splitting water with only solar radiation. So in this slide we can see the photocurrent and solar to hydrogen conversion efficiency as a function of band gap energy. Here we can see that on decreasing the band gap energy of a semiconductor, we can increase the solar to hydrogen conversion efficiency and photocurrent density under one sun illumination. Therefore, in the INSOL project, we are working on a new material system with earth abundant elements. This is a very young material consisting of 4 elements: copper, tin, zinc and sulfur. And the cost of this material is also very less as compared to other semiconductor material. So in this project we will work on a casterite type semiconductor Cu2 ZnSn4 system, as it has band gap 1.5 electron volt, which is very suitable for PEC application, and also it has high absorption coefficient in a visible region. Also it shows the robust p-type conductivity. But the major problem associated with the CZTS is its position of valence band, which is not properly aligned with the oxidation potential of water. Therefore, we will use a nanostructure of CZTS with a graphene, MOS2 and other metal oxide semiconductor to utilize the full spectrum of solar radiation and for the easy transfer of charge carriers. Finally, the modified material will be used in a photoelectrochemical cell for the generation of hydrogen. As you can see in this movie, which I have recorded during my experiments on iron oxide, I got hydrogen on a platinum counter electrode, as iron oxide is the n-type semiconductor. If you are using p-type semiconductor like CZTS, you will get the hydrogen generation on the semiconductor surface. Here, as you can see, this is an n-type material, iron oxide is an n-type material, So I'm getting hydrogen on the platinum counter electrode. In this movie, I gave 0.5 volt as an external potential to overcome the overpotential of the photoelectrochemical cell. So idea of INSOL project is to have hydrogen without any external potential. So, with solar to hydrogen conversion efficiency of more than 4%. So this is the project, and this is my idea of this project. Thank you very much.